Hey there, Patriots. Mr. Love here. First off, I want to thank Miss Garcia for covering that last unit for us. Going to be me this unit. Me and her are swapping off videos. The reason I'm wearing a mask right now is because I'm recording live in class. For the first time in a long time, I've actually get to record in front of my classroom. So, my live students, y'all go ahead and say hi to the people at home. Hi. Hey, yeah, see, they're there. They exist. So, this video is going to be a little bit longer than normal just because... normally I rely on you guys to hit the pause button when we're going too fast, but this time around, since I do have a live classroom, we're going to be giving them time to write stuff. So also if they ask a question, I'll repeat it into the microphone for y'all, and then we will just make it all work. Okay, so starting up on Unit 5, we're starting to talk about triangle congruency. So the first thing is two congruent polygons polygons are congruent if and only if their corresponding parts are congruent. And we'll talk about the corresponding parts quite a bit here in a second. Now, corresponding parts are the matching angles and sides. Now, when I say matching, what I mean is, like for example, on a triangle, let's get my face out of the way here. You've got three sides and three angles. The two shortest sides correspond. The two longest sides correspond. Two largest angles correspond. Two smallest angles correspond. Okay? So, whenever I start talking about my corresponding angles, I'm going to say that angle A, which is my 2 mark angle, is going to correspond over here to angle H, which is also my 2 mark angle. Angle B is going to correspond to the 1 mark angle, which is angle J. And then the third piece is angle C and angle K. Now, corresponding sides, let's go with here, side AB. Now notice that side AB has 1 mark on it. That's my 1 mark side, which is going to correspond here with HJ. Then our 2 mark sides are BC and KJ. And then our 3 mark sides are going to be AC and HK. No. Yes, HK. Now, notice I haven't said anything about whether or not these things are congruent. All I've said so far is that they match each other because angles K and C are my smallest angles. Angle B and angle J are my largest angles. They correspond because of that. Now we're going to go through and evaluate, are those matching parts congruent? So I look at it and I can see that angle A and angle K are congruent. I'm sorry, angle A and angle H are congruent because they have the same, or they're marked as congruent with the angle arcs. So I know that these guys are congruent. And the same is going to be true of all of these. Same thing with all of the sides. Now, this theorem at the top says 2 polygons are congruent if their corresponding parts are congruent. So, since I have 3 sets of corresponding congruent angles, 3 sets of corresponding congruent sides, that then means that the 2 triangles are congruent. Now, we've talked a lot about when and where order matters. This is the first time where order matters a big, massive, hairy deal. Okay, you have got to be very, very careful whenever you're writing congruency statements. So here's what we're going to do. We're going to call this triangle A, B, C. Now, the order of the first one that you write down does not matter. I could have written a triangle BCA, BAC, CA, whatever. The first one you write down does not matter. What does matter is the second one, because this congruency statement is actually a roadmap to the corresponding congruent parts. So, whatever angle I place first must match with angle A and must be congruent to it. So, which one matches with angle A? Well, angle A matches with angle H. Then, second I had angle B, so which one corresponds to angle B? J. And then angle C corresponds to angle K. So you got to make sure these are written in the right order. And whenever I give one of these to you, whenever I say triangle ABC is congruent to HJK, then you know for certain the things in the first positions are congruent, second positions are congruent, and third positions are congruent. Also, you can read side links off of this. I can go through and I can say that BC is congruent to JK because it's position 2, 3 on both of those. I could also go through and say that side AC is congruent to HK because that's the wraparound, the first and last. Those are also going to be congruent. Okay? Tons of information in this one thing. Probably one of the most detailed statements we'll be writing all year long. And because of that, I need you guys to be careful with how you're writing them. Always make sure that you're writing them in a way that things are going to line up. And the first ones are congruent, seconds, and thirds. Okay, third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of a triangle are congruent. This one, once you start seeing it, is honestly feels a little bit silly. We know there's 180 degrees in a triangle. And so if B is congruent to J and C is congruent to K, then I know that angle L must be congruent to angle A. Okay, 5 examples, and then we're done. Okay, show the polygons are congruent by identifying all the congruent corresponding parts. Now, we talked about triangles. There's also all those properties still apply to greater order polygons as well. Well, with the exception of the third angles. That only applies to triangles. But let's go ahead and write these out. All of my different sides are PQ, QR, RS, PQ, QR, RS, and then PS. My angles are angle P, angle P, angle Q, angle R, and angle S. Those are all from that top triangle. Top quadrilateral. Now, let's see if we can match up the corresponding parts. And honestly, this is easier to do from angles than it is from sides. So let's look at angle P. Angle P is marked as a one-arc angle. Which one in this bottom quadrilateral is going to match with that? Angle P is congruent to what? I'm sorry? G, yes. So what we say is that it is congruent to angle G. Now, which one's congruent to angle Q? 2 arcs and then 2 arcs. Yes, you're right. Angle F. Okay, angle R is 3 marks, which is congruent to angle E. Thank you. And then angle S is congruent to angle, S is 4. There you go. Angle D is 4. Okay, now let's look at sides as well. Here we've got PQ as my 1 mark side. What is the 1 mark side on the bottom one? FG. Okay, which one is going to match with QR? QR is 3 marks. I'm sorry, which one? EF or FE? Yeah. Okay, RS. 3 marks matches with DE. And then PS is our last side, is congruent to 2 marks to DG. I need my line segment symbols on all those. You know, I can't remember. Have we talked about that symbol I'm using? Have we talked about it before? This guy? We have? Okay. Okay, so I look through here and I want to see, do the angles on the sides all match? Okay, PQRS, PQRS. They go around the outside. Okay, and by that I mean I'm not skipping across. I'm going around the outside. Also GFED, GFED, again goes around the outside. If I was to cross back and forth, that might be a problem. But I also want to make sure that my side links are going in that exact same order. I started at P to Q to R to S. Well, here I go from P to Q, Q to R to S, and then S back to P. And I'm following that exact same pattern on the bottom one. Okay, sorry about that. I had a small interruption. I actually honestly forget exactly what I was saying before we cut the recording. Basic idea, as long as everything's going around along in the exact same order around both of them, then we're actually going to use the angle measures, or the angles list that we've made to come up with our congruency statement. We have to go around the outside. We can't zigzag across, which we've already confirmed those do. So what we're going to say is that polygon PQRS is congruent to polygon, and now go in the exact same order, because again we need them to have corresponding parts in the right spots. So since P is first, then G must go first. Since Q is second, then F must go second, and so on. Now again, when I said order doesn't matter, or order does matter in some cases but not in others, here's what I mean. If I had done this as SRQP, that's fine as long as my second set matches with it. So S matches with D. We see that over here. So in that case, D would have to go first. Now R is second and R matches with E. So we would just have to put them in the correct order so that all the corresponding parts match up. Okay, moving on to number 2. Number 2 tells me that triangle ITP is congruent to triangle NGO. Now, because of that, I can read this and use it as a roadmap to know which corresponding parts are congruent to each other. So I can look at this and it wants me to find the value of X and Y. Well, I can see that angle O has a Y in it. Angle O is in the 3rd position there, and also P is in the 3rd position. So I know that angle P is congruent to angle O. So I look at angle P, right here is 40 degrees. Now I can make an equation out of that and say that 6y minus 14 is equal to 40. And we've got to use that congruency statement as a roadmap. Now we're going to solve for y. We're going to add 14 on both sides. And that gives me 6y is equal to 54. And now we're going to divide both sides by 6. And that leaves me with y is equal to 9. Okay, now I'm going to find x. As I look at this, I see that the only equation that has x in it is over here on side NG. Now I look at my congruency statement and I see that NG is in positions 1 and 2. Now that also tells me that positions 1 and 2 over here, IT, NG is congruent to IT. So IT is 7.5. So I know that x minus 2y is equal to 7.5. And now, since it has both an x and a y in it, I'm going to substitute in, because the y is 9. And now we're just going to simplify. X minus 18 is equal to 7.5. Now add 18, and x is 25.5. Okay, any questions on number 2? All right, I had an but no actual questions. Okay, number 3, same idea here. I'm going to start with my x's this time. So I can see that here I've got an x, and that's in angle GFH. So whenever I look at my congruency statement, I'm going to look for angle GFH in there. Now that happens right here, GFH. That happens in positions 3, 2, 1. Now I know that that is going to be congruent to, again, positions 3, 2, 1, JHF. So angle JHF. Now I go and look at my triangle, and I see that JHF is this angle here. So now I can say that 6x plus 8 equals 35. Now we run our solving steps. Subtract 8. 6x equals 35 minus 8 is 27. Divide everything by 6. 27 divided by 6 would be 4.5. Now for our y's. I look at my y, and it's on side FJ. Now FJ is in position 1 and 3. Now position 1 and 3 is HG. So I look over at HG and see that it is 2.5. Now in reality on this one there are the only 2 sides in there, so you probably could have skipped that through, but we want to go ahead and make sure that we're reading the right pieces here. We just need practice using the congruency statement as a roadmap. So we set it up, 2y minus 3 equals 2.5. So that gives me 2y is at 5.5. Divide by 2, and that gives me y equals 5.5 divided by 5 is 2.75. All right. Any questions on number 3? Okay, number 4, write 3 congruent statements and 3 angle congruent statements and 3 side congruent statements. Okay, so here I've got triangle cat and triangle dog. Now, here I've got angle C, angle A, and angle T. And I know that those are congruent to, Well, angle C in first position is going to be congruent to angle D. Angle A in the second position is going to be congruent to angle O. And then angle T in the third position is also congruent to angle G in the third position. And now for side lengths, we're going to have position 1 and 2 CA, position 2, 3 is AT, then the wraparound position 1 and 3 gives me CT. And now we do the same thing. 1 and 2 is DO. 2 and 3 is OG. And then position, or the wraparound CT and DG. Just a word of warning here about three-letter combinations that make words. Don't always take for granted that they're going to make words whenever you make these. Because one of the things that could happen, and this is an entirely separate problem, not related to this, other than the fact that it's got the same letters. And let's just go ahead and mark 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so I've set up two triangles here. And now I'm going to do DOG. If you see the pattern there of CAT and DOG, and you automatically just write cat and dog, that's the kind of problem that we like to throw out there as math teachers to see if you're paying attention. Because whenever I write that first one, triangle cat is congruent to. Now remember, I'm not just writing a word. I'm looking for what matches. So angle C is my 1 mark angle. My 2 mark angle is angle, my 1 mark angle is angle G. So here C corresponds to G, so G goes first. Here A corresponds to D, and T corresponds to O. So this would be the correct statement for this set of triangles. So don't get hooked on the idea of it's got to be a word. Okay? I'll actually purposely throw that out there sometimes to try and make sure you're paying attention. Okay, number 5 is very similar to number 3. Angle A, position 1, congruent to D. Angle B, position 2, will be congruent to angle E. And then the last one, C, is congruent to angle F, position 3. Now for the sides, again, take the first ones. A and B is 1, 2. Congruent to 1, 2, which is DE. BC is now going to be position 2 and 3, corresponds with EF. And then the wraparound AC, position 1, 3, matches with DF. Any questions? Okay, so that's all we got for you today. Overall, that's a pretty straightforward lesson. Things will get a little bit more interesting next class period. We're going to start doing some triangle congruency shortcuts, and we'll talk about why that's all necessary and everything. As it is, good luck on the assignment. You all have a good day.